I am here to talk to you for a bit about triangle congruence theorems. Now, in triangle congruence theorems, there are these things called SAS, AAS, ASA, and HL. It is basically four different ways you can prove triangles congruent. So if you forgot, triangles are considered congruent if all three sides have a congruent part compared to the other one, and each of the angles also have a corresponding congruent angle in the other one. So all three angles here are congruent to the three angles here, and all three sides here are congruent to those three sides here. So everything is the same shape, both the sides and the angles. What this does is it says you don't need all of this information in order to answer whether they are congruent or not. What A, S, and HL stand for is A is angle, S is side, H is hypotenuse, and L is leg. And what it's saying is knowing these ones is enough to prove them congruent. So if you have two triangles and you know this side is the same, these angles are the same, and these sides are the same, that is enough. You do not need to know the rest of it, and you can already tell that these two triangles are congruent. Or um, if I was to, let's just do one more. If I was to have angle, angle, side, if I have this angle, another angle, and then the next side, it is saying that that is enough. This is enough information that we can assume, well, not assume, but it is possible to find that that means these two have to be the same. These two have to be the same, that this angle has to be the same as that angle. But you only needed those three parts, and you could find that the rest are the same. So that's what this is about. But the question is why? I mean, it's one thing to study and just kind of memorize these four and how to recognize them, but this video is more to explain why. Why do you only need those three things, and all of a sudden you know that a triangle exists in this way? It has to be any other triangle is existing that exact same way, that they are congruent. And that's what I've made these two slides about that we are going to be looking at. So this is for people interested in knowing why. The first one I want to look at is a side angle side. So let's go ahead and start with a side angle side explanation. What I have done here is I have created an angle. I put these little dots here because I don't know how long the side is. The whole point right now is that we're looking for as little knowns as we can. So I have given this angle. It is definitely this big, but I don't know how long this side is, and I don't know how long this side is. And same thing with my second angle. This is just if I have one angle, and I'm realizing now we're not actually doing side angle side. That's my next slide. What happens when we know that there are two angles? Okay. Well, as you can see right now, there's no like one triangle we can make. Maybe the side is very small, so I have this very small triangle I'm kind of making. Or maybe it's bigger, in which case there's going to be like this bigger triangle being made. But because this thing, we don't know how long it is, we just know, excuse me, we just know that it can be anywhere here. So what happens is if you decide to finally actually make a distance, let's just pretend I want it to be exactly here, then I can define this distance right there. And as soon as I define that, then I definitely have this angle, I definitely have this length, and I definitely have this angle. You can see that that makes it have to match up. If you continue this dot, 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 it makes it into an actual triangle. And this triangle is unique. You can move it anywhere and it's a congruent triangle, but it is exactly one thing that's being made. And what is this? Well, we were given this angle right here. And I just put a side between them. So this is considered angle side angle. So that's the explanation for angle side angle. So I'm going to undo all of this and go back to when we just had those things again right here. And I'm going to say, well, what if instead of defining the thing on the left, if I decided to make this unknown right here? I wanted this exact length off of this angle. So from this point and this point and this angle. Well, then you can do the same old kind of matchup thing. Once again, it can go here. You just keep going until eventually you'll see that this will match up exactly right there. And once again, we have created a unique triangle that you can move anywhere you want. And in this case, we had an angle here, and a side there, which goes angle, angle, side. And that is the explanation for why angle, angle, side works. Because if you have that information, it makes the angle have to line up to be in exactly one place. There's no other opportunities. It can't like go over here and connect. It can't connect here. It has to connect exactly in that one spot. So angle, side, angle, and angle, angle, side. That is their explanations. Angle, side, angle, and angle, angle. So we're good on those two. Boom, 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 boom. For side, angle, side. I have created one side already. We'll just say that is the length. We definitely want this one side. And then for my other side, I'll just make this length right here. So keep in mind, the actual angle does not matter. I'm just keeping this the same length. Notice I'm doing my best to keep it the same length, but the angle does not matter. That can change. This angle over here can change. Unfortunately, I have to delete the line because that's the way this program works. So what I have here is two sides. So what happens is if I do define the angle, if I decide, yes, definitely I want this angle right here to be exactly this angle, then there is only one triangle you can make, and that is connecting these two together. And congratulations, you just made yourself a triangle. But that's only if you have this side, and the angle between them, side, angle, side. So if the angle between them is defined, then there's only one triangle you can make. You just connect the endpoints, done. But what happens if you don't? What if we decide to keep that angle just, whatever? Is it enough to have an angle after that? Let's find out. So this time, I'm just going to make it, let's say, this distance right here. But this time, I want the angle over here to be set. Well, the thing is, because we're changing the angle, it's kind of hard to show, but because the whole angle thing can change, if we like group these together, I don't know if it's going to work out super well, but it's worth a shot. I can click on the right thing, which I can't. There we go. So as you can see, it's not doing a great idea of going around with it, but when the angle changes with this thing, if you were to try to rotate it, it rotates the other angle as well. So just to do two different ones then. We will say those two are the same length. So if I was to make an angle like this, then over here the angle would look kind of like this. Like if you rotate it, hopefully you can kind of see it looks like that. That's what I'm going for. And it's like, well, is that enough to make a unique triangle? And it turns out the answer is no. Because if you were to try to do this, you'll see right now it's not actually a triangle. It would need to open up till about like maybe here-ish. That way the angle, when you do it, would actually match up into a triangle. But it actually gets more complicated than that. And the easiest way to show that is actually with a circle, which might seem like, why are you talking about a circle? But in math, a lot of times mathematicians use circles to show equal distances. Don't know if you guys know what a compass is, but basically it's an instrument that you can measure a distance like this, and then you can make a circle around it. So like if this was the distance I wanted to look at, if you were to make a circle, probably about that big, around one of the endpoints. So like if this is the center and I put it here, let's see if we can just match this up a little bit. Boop, good enough. Okay, so if you do something like this, then this circle right here shows you every single place that you could have a line that is the same length. So this length is the same as the other. This length is the same as the other. This length is the same as the other. Like all of these have to be the same because the radius is the same everywhere. And I'm going to use that fact. So hopefully that makes sense. But basically you can use a circle to make an infinite amount of congruent lines. And here we go with that. I'm going to make this one line here. And if I was to try to make another line segment a certain length, so once again, I'm making it a certain length. The angle is still up for debate. But if I was to choose like this length, anywhere around that point. So right now, if it was here or something like that, we are doing this side is the same, this side is the same, and this angle is the one that's changing. So this angle can change anything right here to make a triangle. But as you can see right now, this doesn't even make a triangle. It has to connect over here. So this circle is too small. It is impossible to have something with this side and that side, which means we have to make the circle a bit bigger. So it's this uncertainty that I'm talking about that makes it not a theorem. That's kind of what I'm going with this. We have a side, and we're making an angle. And side angle is not one of the ones we're doing, right? There's no SSA. And I'm just showing you that. So if I was to make this possibility of an angle a bit bigger, for some reason it's not letting me select this thing. Well, it's not letting me select the orange one anymore, but okay. So this is once again going to be if I used this as come on, the center length. So I'm keeping the segment length the exact same, it's just the angle up top is changing. And as you can see, this actually creates two possible triangles. There's this triangle right here where this side is constant and this side is constant and the angle is changed, but you could also go over here and make another obtuse triangle. So this side is the same, this side is the same, but it's making two different triangles. So this whole thing with side angle is not working. However, there is one other thing that we have not tried. That is the little sweet spot when this little circle is small enough to hit at exactly one point. In which case, there's only one possible triangle, right? These don't work, but all of a sudden, this length exactly works right here. So then the question is, well, what type of triangle is this? Well, maybe you heard me saying before that if you matched over here, it was an obtuse. If it matched over here, I'm sorry, this one is acute and that was an obtuse. If you're straight in the sweet spot, this turns out to be a right triangle. So in this right triangle, we're saying that we know the hypotenuse and we know this leg. And if we have that hypotenuse and that leg, it just turns out the other angle isn't mattering as much. So hypotenuse leg is another one that actually works. And that's it. That is the explanation. Hopefully this figure somewhat made sense. It's kind of hard to explain. I wish I could use my hands, but right now I'm only presenting my screen. But there you go. Once again, very, very, very important is that side-side angle does not work. It does not work because you don't know what this little angle is here. I'll try to show it one more time since that is the most confusing part. So need to make this a little bit bigger to show. Okay, so once again, we have this side constant, right? So this is the side, it's just a side. I'm labeling it side to show that that's what it has to be. The other side is going to be over here. So we know for a fact this side is this length. Boom. But because the angle can change, right? The angle we are changing over and over again. This one doesn't matter as much. We don't care about this bottom one. But if you change this, this is a possible angle right here. This is a possible angle. We have just made a triangle, right? So we have just made a triangle with the side, and then an angle made. But if instead of doing that one, we moved it on over to over here, we once again have a triangle. Boom. And in this triangle, like I saw these triangles, so hopefully you understand them. If not, I'm going to go ahead and delete this. In this triangle, it is true. This side is the same length as this side. This side is the same as this side. And this angle is the same as that angle. So that is true. You can see that those two sides on the left, they are in fact the same. You can see the angles in the bottom left are exactly the same. And it's harder to see that the lengths on the right side are the same, but they are. Maybe it helps. This is like an isosceles triangle. So this length is the same thing as that length. So it is a fact that you have, if you want to call it this way because it's easier to see, an angle side-side problem. Angle side-side problem. It does not work because you have those three pieces of information. The angles do match, the sides do match, the other side does match, and yet it is not working because they are two different triangles. I call them the pain in the angle side-side problems because it looks like maybe it should work, but it does not. So they call it side-side angle instead of angle side-side for reasons you are welcome to guess at, but that is the explanation of why it does not work. And these are just the ones. So we did all of them now. But also important, make sure it is not side-side angle is something to note. That is why hypotenuse leg is okay. Technically, hypotenuse leg is side-side angle. It's just in a right angle. I know if it's a right triangle, then you already have this angle. So if you know that and you know that, this is technically side-side angle. But it doesn't matter because it is exactly a 90-degree angle. There you go. I think I've rambled enough. So hopefully this makes sense. You'll eventually get practice elsewhere of how to identify which one of these is being used. But these are explanations, and I hope you found it interesting. If you did not find it interesting, then you just wasted a couple of minutes of your life, and I apologize. Have a great day.